CIT 1122, instructional video, packet tracer 7-10. This is the first of two videos for this chapter. This one's more of a step-by-step cookbook lab. Essentially, router 2 is going to be a DHCP client, and it's linked to the internet. So we'll set up the interface connecting the internet to router 2 as a DHCP client, and router 2 will also act as a DHCP server for the networks connected to router 1 and router 3. So we'll create two DHCP pools, one for the 10 network, one for the 30 network. We'll set up networks, gateways, excluded addresses, and DNS servers, not in that exact order. We'll also set up R1 and R3 as relay agents because DHCP version 4 is a broadcast technology. Broadcast messages created by PC 1 and 2 would not be forwarded to router 2. So we have to get a little help from R1 and R3, and we'll use the IP helper address command to make that happen. And that's the extent of what's in this chapter. It's a pretty good chapter. It's a highly used technology. We use it all the time. Most people don't really want to know about IP addresses, and DHCP is a really good way to programmatically ensure that when a machine joins a network, the end user doesn't actually see the IP address. Okay, so cool. All right, starting with part 1, configure the excluded ranges. It is generally preferred to set the exclude ranges up first, because if you set your pools up and then you do your exclude ranges second, then some of the addresses in the exclude range could be passed out first. So generally put your exclude ranges in first time through, and we'll go ahead and start with that. So on R2, we're going to set our exclude range for router for the LAN off of router 1, which is the 192.168.10.0 network. All right, so let's go to R2 and let's go ahead and set this up. Also, OSPF has been set up in the background of the routers already. Oh, that's a lie. It looks like show IP route. It looks like EIGRP. EIGRP has actually been set up. Don't tell anybody we're not using EIGRP in the CCNA anymore. But the point is this. A routing protocol has been set up. And so R2, R1, R3 all have internet connectivity to each other. So no worries there. Everything's going to forward and work the way it's supposed to. We're not going to have to set up any static routes or anything. We're just going to do DHCP. So let's go back to the lab and let's get to step 1 here, substep A, where we're going to set up that exclude range for the LAN off of R1. So config T and IP DHCP exclude address, and then we do this to the first and then the last. So 192.168.10.1 through 192.168.10.10. So that's a range. It's a range value. You don't use a dash with Cisco and ranges. You just use a space, first and last, bam. Those addresses have now been excluded. So when we create our DHCP pool for the 10.0 network, the first address that could be passed out would be 10.11. And let's go ahead and make that pool. So whenever we create a DHCP pool in Cisco, on a Cisco router, we name the pool first, and then we give the attributes to the pool second. So whenever we're setting up a pool, the attributes, the name of the pool has to be unique, cannot have spaces. And the attributes would be network, default gateway, DNS server would be the minimum that we would need, and that's exactly what we do in this lab. So let's make that first pool. So we'll do IP DHCP pool and R1-LAN. Please use capitalization as it is in the lab, otherwise you will not score the points. And we're now in DHCP config mode, so we're going to go ahead and put in those basic attributes to a DHCP server. We would generally need a network value, a default router, default gateway, and a DNS server. So let's go ahead and add those 3 things. Network, 192.168.10.0, subnet mask, /24, default gateway, default router is the command name on this, just to make it a little more difficult, and DNS server And the DNS server is actually, it's kind of behind here. It's right here. And just trust me on this one, it's 20.254. So 192.168.20.284. And that's done. Cool. And we'll do a quick exit there. Great. Now that we've done our first, created our first DHCP pool, let's create a second DHCP pool for the attributes of the LAN connected to R3, which is the 30.0 network. So let's name it. Oh, sorry. Let's do an exclude first. Let's do exclude range. So IP DHCP exclude addresses, and we'll go 192.168.30.1. 30.10, 30.1 through 30.10 will be excluded. So we've excluded the first 10 addresses, and we're now ready to create our pool. The pool is going to be called R3-LAN. So that will be IP DHCP pool R3-LAN, and we'll do network. One 192.168.30.0/24. Perfect. Default router is going to be 30.1. How do I know that? I know that because I know that this interface is 30.1. If we look at that on this on R3, that G0/0 is 30.1. I happen to know that from before, but so that's that. And the DNS server is going to be the same DNS that we set up on the one for the LAN off of 1, which should be 20.250. Is it 20.254? 20.254, yeah. Done. Nice. Okay, those are created. Fantastic. So the two DHCP pools are now built. Let's move down to part 2, configure DHCP relay. Okay, so here's the deal. Right now, PC1, let's take a look. It's set for a static IP address. Let's set it for DHCP and see what happens. This is going to fail. And it's going to fail because it gets an APIPA address of 169.254. It fails because the way DHCP works is it starts at the host and finds the server, and then the server finishes the deal. So a DHCP request is made, PC1. Hey, I need an address. It's a broadcast message. It goes across our LAN. If there's a DHCP server here, it'll respond. Since there is not, there is no response and it fails. Now, what we're going to do is this, is we're going to say specifically if DHCP broadcast messages are found, then they'll be repackaged and sent to a particular IP address. So for R1, that IP address is going to be the interface serial 000 on R2, because the pool of addresses that we are looking for to pass out to PC1 is here on router 2. So the IP helper address command that we're going to use is going to be sent to, it was just there, 10, I can't move this again, sorry, 10.1.1.2 is where we want to send that. Same thing is true over here of router 3. Router 3, broadcast messages are not going to pass across the router unless you use the IP helper address command. And in this case, the next hop IP on router 2 is 10.2.2.2. So we'll use that one. So 10.1.1.2 on the left, 10.2.2.2 on the right, or 10.1.1.2 for router 1, 10.2.2.2 for router 3. And that's the intermediary networks. All right, cool. All right, let's get that out of the way and let's set that up. And that's all they're getting to here. So interface G0/0. Remember, the broadcast comes in someplace. It's going to come in here on G0/0. It's going to get repackaged and sent to this interface 10.1.1.2. Very easy to do this. Config T, int G0/0, IP helper. IP helper address 10.1.1.2. And that's done. At this point, PC1 can get an address. Let's see what it looks like now. And it got one. It got 192.168.10.11. Now, in your mind, try and figure out what address PC2 is going to get when we set that one up. So let's go to PC3. We're going to do the exact same thing. G0/0 is connected to R3's LAN. It is 30.1. Its address is 192.168.30.1. And it is going to repackage and send any DHCP request to router 2 to 10.2.2.2, which is the next hop for it. Easy enough. We'll just go ahead and do IP helper address, and that's going to go to 10.2.2.2, which is this interface right here. That's all you got to do, and that will relay. That's called a DHCP relay agent. You set up a relay agent today. Let's go to PC2 and let's see what happened. If we do DHCP, it should work, and it did. And once again, it's 30.11. Mask is the same as the rest of the network. The default gateway is the router interface. The DNS server is whatever you set it as, and life is good. Things are looking up here. So we've set those. Those look good. And let's go down to part 3 here. And for part 3, we're going to set up a Cisco router interface as a DHCP client. This is a common option for interfaces that are connected to internet service providers, or the router is just going to get a DHCP address just like any other PC, just like our PCs did. Very easy to do. So we're going to just first identify that this interface is G0/1, and then we're going to configure it that way. You've done this before, so we're just going to go int G0/1, and we're going to set it to get a DHCP address from the internet side. So remember, it's pointing out towards the internet. So we're going to do IP address, and then we're going to do DHCP. It's that simple. No shut. And it's on, and it works. And that's 100%. So pretty fast lab, pretty easy lab. I'll see you in the other lab that we have for 7, which is like 7.4 something.